Okay, the robot has two sensors, a distance sensor and two of this, which is a line tracker. So you have the usual connections. For the line tracker, you have three connections, one for ground, then you have the for the 5 volts B plus or BCC, and then you have S for signal. Be careful in connecting the wires because the labels might be different. And then for the distance sensor, it has four connections. You have BCC, that's 5 volts. Then you have ground, then you have trigger and echo. We'll discuss the trigger and echo later. But let's connect first the sensors to the microcontroller. So we have echo and trigger. Now connect echo and trigger to pins 2 and 4. Same with the robot. This is echo 2. Wait. Okay. Trigger first. Trigger 2. And echo 4. And then I'll connect BCC to 5 volts. BCC is over there. This is 5 volts. Now this red. Then ground to ground. Okay. And then for the line tracker, I'll double check. So I have ground over there. Ground and by plus or VCC. I actually ran out of red and black, but I'll use the next best thing. So for black, I'll use brown instead, and for red, I'll use orange. And this is for ground, and this is for Starbucks or BBS or VCC, and this is for the signal. And I'll connect this to A2, same with the one with the robot. But the robot has two. Okay. There. So let me just double check connection. So this is A2. Again, always check the label before you connect the wires. So ground is connected to ground, and B plus. Sometimes VCC is connected to 5 volts. Okay, check. And VCC is connected to 5 volts. And then ground connected to ground. Then trigger is connected to pin number 2. And echo is connected to pin number 4. Okay, check. Okay. And then let's write the code. But please take note that the line tracker has uh, an adjustment. You can change the sensitivity level using by turning this left or right, but do it gently. So the setting is always at the middle. If you need to increase or decrease, just do it gently. So I'm going to plug it in and let's test the line tracker. The line tracker is meant to search for a line, and the line is usually black. And if there's light or there's too much light being reflected back, it would assume or conclude that it's on a light surface and it should light up. So that will be your indicator that the sensor is seeing a white space, a white surface, not black. If that disappears, then the sensor is assuming that it is on a black line because there's no light being reflected back because there is no surface. Okay. Then let's go to the code and let's add a constant variable int. Let's say that is the left line tracker. L tracker is equal to 16. Okay, or also known as analog pin number 2. But we will use it as a digital pin this time. And $17 for the right line tracker. But we don't have a second line tracker here, but we'll use the code later with the robot. And then for the trigger and echo pins for the distance sensor, we'll do that later. So I'll go to the loop, and then what I'll do is I'll make the speaker beep whenever the line tracker sees a white surface, because as of this moment the line tracker is concluding or assuming that it's on a black line because there's no light being reflected back. So this part really is emitting infrared light, and which is being received by the same sensor, which is the receiver, transmitter receiver, and the entire sensor or circuit is reacting to the amount of light being reflected back. So I'll use a structure, a control structure. So I'll put the condition there. What I want to happen is for the speaker to beep, and let's say maximum power for 10 milliseconds. So what is the condition? I'm going to use digital read and indicate the pin number, and in this case the pin number is 16, and instead of putting 16, I'll use L tracker, and I have to set the pin mode for L tracker as input. So this time we're not sending a signal out. It's the sensor that will be sending the signal, and the microcontroller is set to accept or to set the pin for standby for incoming signals. So we have to set the pin for input. So we use digital read Open close parenthesis inside is the pin number, and in this case, we have saved the pin number to L tracker, or the variable, which is a constant variable L tracker, and we'll make it beep if the reading is equal to low. The sensor will only give one of two values, which is high or low. High if it's seeing black, in this case it is. Low if it's seeing a white surface. So let's upload. Please check setting and upload. I may have to change the setting and upload again. Okay, let's test. There. So it's currently sending 1 or high, and if we put this in front, we'll see a reflection, and then it will send low. And we said in the code that if it's low, it should be. All right. Okay. Now, let's make a function for this sensor. So instead of using digital read all the time, we are going to make a function, and the function will not be void. The function will be reporting a value, and since the value is either 0 or 1, we'll make the function an integer. So int, and then let's say left tracker, open close brackets, and then here we just say return digital read L tracker. Simple as that. So again, left tracker will return a value based on what it gets from digital read, which is using the pin number 16 saved in the constant variable L tracker as basis. So it will check that pin if it's high or low. And basically high is 1 and 0 is low. So we'll do the same for the right line tracker, which is not here in our setup, but which is present in our robot. So we're just getting ready. And here in the main code, I can just change this part to left tracker, which is shorter than what it used to be. And let's upload and check if this will work. So if it's low, it should be. All right. So same goes with the right line tracker, which is not in this setup. We'll try it out later. And let's proceed with the distance sensor. The distance sensor is different from the line tracker because this is not active all the time. You have to activate it or trigger or send a trigger signal for it to activate, and wait for the echo because basically this is an ultrasonic distance sensor. It uses sound to determine the distance of an object. As you can see, you have the label there, P for transmitter, and you have R for receiver. So sound will be sent out through the transmitter, sent out, and the receiver will wait for it to return. So that will be the echo. And we will follow the instruction from the manufacturer. And remember, when you are going to add a new sensor on the robot, you have to read the manual and find out how to use the sensor. In this case, the code that I will put here is based on the instruction manual. So I'm going to name the function as distance, and it will be a float. It will return a value with decimal places, and it would need two things for it to work. And those two things would be the pin numbers where the trigger and the echo pins are connected to. And in this case, the trigger is connected to 2 and the echo is connected to 4. So let me create the variable first that will handle those values. So int or trigger pin, and then another one for echo pin. Okay. So we need for the distance function needs those pins for it to work, and we have to set the pin mode for the trigger pin and for the echo pin. And the reason why we do not put it in the setup function is because you can actually set the pin mode anytime, anywhere in your code. So here, I'll set the pin mode of kick pin to output, because we'll be using that to send out the signal from the microcontroller to the sensor, because we have to trigger it manually from by sending a signal. And then we have to set the pin mode of the echo pin to input, because we're going to wait for the echo to return and make the computation for the distance of the object. Okay, so we have set those pins, and according to the manufacturer, we have to send a signal to the trigger pin for it to activate. What signal? So we are sending a digital signal, and it has to last for 10 microseconds. So to do that, I'm going to send a signal using digital light. Send a signal to kick pin. What signal? High. And then I'm going to delay or make it wait for 10 microseconds using this function, delay microseconds, before I remove the signal or send a low signal. Okay, so that should trigger the sensor to send a signal out. However, to be sure that there's no signal before we send a 10 microsecond signal, I'm going to send a low signal to be sure and wait for 2 microseconds. Okay, so it's basically just emptying the line, making sure there's no signal on the line or on the pin before I send the high signal for 10 microseconds. There. Okay. So this would trigger the sensor to send a sound, and then we have to wait for the sound to return. And the echo pin will be our way to find out if the echo has returned. And we will use another function to make things easier for us. So, pulse in will basically wait for the echo pin. So we are telling the function that it will monitor the pin for the echo to go high. So it will wait until the echo pin goes high, and then it will basically just count the number of microseconds it takes for the echo to return, or for the echo to be received. So let's say duration is equal to pulse in echo pin high. So pulse in will wait for the echo pin to become high and save it in duration. So I have to declare duration here. So duration will be long because it will be beyond the range of an integer. It may be beyond the range of the integer, so it will be a long integer variable. Alright, and then we are going to return finally the value or the distance by dividing the duration by 2. Why do we have to do that? Because the pulse in will basically count the number of microseconds the sound has come out and returned. So we only have to get the distance between point A to point B, not from point A to point B and from point B to point A. That's why we have to divide the value by 2. And we have to further divide the result by 29.15 because sound travels at 29.15 centimeters per microsecond. Or 29.15 microseconds per centimeter. You can check that out later, but let's use this formula and let's find out if it works. How would you know if it works? So here, again, let's check the function. It needs 2 values, the trigger and the echo. And then it does all of these things, then results to a value which is in centimeters. So here, what we'll do is I'll change this to distance. And 4. This is for the trigger. This is for the echo. And we are going to get a value from distance. And we're going to compare that with 10 centimeters. So if the value we are getting from distance is less than 10 centimeters, it should beep. Let's check. So it's uploading. Let's move this further. We're done uploading. Let's check. So we have an object and I'll make it move. Okay, so let's move this further, and again. Okay, so it works. So, all right, that's it. Now, let's make things a little bit better. We are going to use the serial monitor and monitoring the values of these sensors. Okay, I'm going to set the serial monitor to 9,600 characters per second. That's the speed of transmission. But because basically serial communication is meant to send data to another microcontroller or another device, but instead we will use it to monitor the values of the variables or the results of the function. And to do that, let me just erase this. I will use serial.print, and I'll say distance. Then I'm going to use serial.print again, and then this time I'll use the distance function. I have to specify the pins where the trigger and echo pins are connected to, and then I'm going to use serial.print again, space, and then for L tracker, and then proceed with serial.print again to print left tracker, the result of left tracker, so it can either be 0 or 1. And I'll copy this for the right line tracker. I'm going to try it out later on the robot, but I'll use print line here. So after printing, move to the next line. So let me open the serial monitor to make sure that the setting is both new line and carriage return is there, is selected, and then the baud rate or the speed of transmission is 9,600, same as what we placed here. So this is very useful in monitoring the values or for troubleshooting your code or checking out things with the robot. I'm going to run or upload. Okay, so you have the distance there. L tracker is 1. R tracker is 0. So currently, just like what I said a while ago, the left line tracker is currently assuming that it's on a black line because there's no light being reflected back. And if it's on a white surface, it should say 0. Of course, if you don't have anything on the right line tracker, so we're not getting anything from there. And let's check the distance sensor. So we can say that the distance sensor is working. So we'll use the same code on the robot and find out if the sensors are working. So let me just remove this. I upload the code to the robot. So they have the same connection or wiring. And then I need to upload. And focus on the serial monitor. And as you can see, the distance sensor is working. Let's check again. The sensor doesn't really work well if it's too near, but 5 centimeters and further is okay. And the line trackers are sending low signals, meaning if they have not seen or detected a black line or a dark surface. So this is left and this is right. So let's move the right line tracker to the black line. So we should see one, a confirmation that it's on a black line, and then let's move both of them to the same line, and we should see them sending both one or high. So they're both on a black line. So everything works well. Use this for troubleshooting or for checking if everything is working okay. And that's it.